Okay, this is going to be the Algebra 2 Polynomials review for 2014-2015 school year. All right, so you should have this packet, so you can go ahead and follow along. All right, couple things that you want to look at first to determine positive, negative. Basically, every polynomial, okay, and I'm gonna go forward for a second. I want to go to a blank page so I can show you something. Every polynomial is going to be one of these four categories. All right, you're going to have the end points. What I'm talking about, the end behaviors, are either going to be one of these. Okay, so basically, this top part, all of these are positive. These are going to be negative. That's like a negative slope. If you think about that, that would be like negative x squared. So, and this is going to be odds, and this is going to be evens, okay? So everything is going to look like that, okay? So this is a negative slope, because that would be like the equation y equals negative x. That would be like y equals negative x squared. Obviously, this is y equals x squared, okay? So that can help you in the concept of figuring out positives and negatives. So let's go back and look at my examples here. All right, so for instance, that's sort of like a line. The end behaviors is what we're looking at. Line there. All the stuff in between doesn't affect that. So that's going to be negative, okay? The degree, okay? Here's how you figure out the degree. You look at the turn points. You have two turn points. The degree is going to be 1 plus the turn point, okay? 1 plus the turn point. So in this case, this is degree 3, okay? All right, that's degree 3. We already talked about the turn points. There's going to be two turn points there. Okay? All right. Also, the degree, okay, the degree equals 1 plus the turn point. The degree also equals the max number of real zeros. Okay? That doesn't mean you're always going to have that, but you could have a maximum of that. So in this case, the degree is 3. So the max number of real zeros I can have is 3. Okay? Now, here I only have 1. They want you to mark a real 0 there. So I only have 1 real. That means I got to get to 3, so that's got to be 2 imaginary. Okay? So that's going to be 2 imaginary. So when you look at that, all right, understand that the degree, if I'm at 3, these have to add up to get to that. Okay? This is going to be negative, once again, because these are going down, so it's negative. Okay? I got 1 turn point, okay, which is right there. All right, go ahead and circle that. All right, that means if I have 1 turn point, that means I'm going to have 2 degrees, okay? 2 degrees. Whoops, that's not what I wanted to circle. Okay, 2 degrees, all right? That means if I have 2 degrees, I can have max 2 zeros. Now put an X, it's got to cross this line. That means I have 0. So if I have two possible zeros, 0 real, that means I got to get 2 imaginary, okay? As you can see, that totals up to get to that, so I got 2 imaginary in this case. All right, this end behavior is this way, okay? So that's going to be a positive, okay? I've got 1, 2 turn points, okay? All right, that means if I've got 2 turn points, 1 more for the degree, so that's degree 3, okay? So if I got 3 degrees, that's 3 zeros are possible, okay? Now, I've got 1 here and 1 here, but when it touches that line, let me erase that X real quick. When it touches like that, this one's called a double root, okay? Double root, okay? So that actually counts as 2. So that's 1, and then 2 more is 3 real, okay? So I got 3 real and 0 imaginary, okay? Because that's got to total up, all right, to give me the possible number of zeros. Okay, let's scroll up here. All right, this one, they're both going down, so that's going to be negative. Okay, turn points, 1, 2, 3 turn points. Okay, if I got 3 turn points, that means I have 1 more degree, so I have 4 degrees. So that means I got 4 zeros are possible. Okay, now watch, I got 1, 2, 3, and 4. So I can go ahead and mark all those. So I got 4 real. That means in order to get to that, I need 0 imaginary, okay? So I have 4 real, 0 imaginary, okay? All right, this has 1, 2, 3 turn points, Both those are going up, so that's going to be positive. Okay? One more degree is 4. So I've got 4 zeros are possible. Let's talk about real and imaginary. Okay? All right, it crosses once, twice. Okay? So I got 2 real. That means I got a total up there, so that's 2 imaginary. Okay? All right? This one, I have one turn point. Okay? All right? Both those are going up, so it's going to be positive. If I got 1 turn point, I have 2 degrees. So I got 2 zeros are possible. Okay. Now, once again, that touches, there's a double root there. Okay? That's a double root. All right? So that means that counts for 2. So that's 2 real, 0 imaginary. 2 real, 0 imaginary. I already marked that. Okay? Use your calculator to find the coordinates of any turn points here. Okay, so what I'm going to do, hold on one second. Got to pull up my calculator. Okay. All right, I'm going to go ahead and graph this. Okay, menu and graph. All right, x cubed minus 5x squared plus 3x plus 12. Okay, I'm going to draw. I'm going to zoom. Actually, I'm going to do, hold on, I'm going to do F3, exit and draw. So I got that. I'm going to zoom out a little bit, zoom out, enter. So I got that. So I got turn points here and here. All right, so what I'm going to do is I'm going to do G-solve max. Okay, I only got 1 max turn point. So that's going to be 0.3 comma 12.5. Okay, 0.3 comma 12.5. Okay, that's going to be my max, my local max. Okay. G-solve minimum, okay, I've got 3, 3, okay, 3, 3, all right, that's my local min. I have my local max, okay, all right, okay, so that's the turn points for there. Given the graph of g of x on the right, identify each turn point with an x on the graph, okay, so my turn points are going to be here and here. Okay? All right, given the graph at the right, identify the x intervals. Okay? So I'm going to go ahead and let me erase that real quick so I can count. 1, 2, 3, 4, 5. So that's negative 5, 0. Okay? That's going to be 1, 2, 1, 2, 3, 4, 5, 6, 7. So negative 2, 7. Okay? Here are my turn points. Okay? So, just like all these other things, all I care about are the x coordinates. So let's label my arrows, just as a reminder. That's the left arrow, so that's negative infinity. It's going up, so it's positive. Okay, this arrow is a right arrow. Okay, that's what I got like that. Okay, so if I'm doing the increasing, decreasing behavior, this is all I care about. So I start here. That's negative infinity to negative 5. It's decreasing. Negative 5 to negative 2. It's increasing. Negative 5 to infinity. So it says circle all the ones that are increasing. Okay, that's going to be negative 5 to negative 2. Okay? Find the end behavior of this. Now, what I would do here to make this easier on yourself, pick out the highest degree, okay, and its sign, okay, and its sign. So the highest degree in this is this, and it's negative. So here's what I'm going to graph. I'm going to graph just negative x to the 6th power. The reason being is all this other stuff just warps the graph, it stretches it, it puts turns in it, but it doesn't affect the end behaviors, okay? So I got negative 5, x to the 6th, and I'm going to draw it, okay? F3, exit, draw. And as you can see, it's going like this. So, if I'm labeling this, this is obviously, let me move this up a little bit. Obviously, this is a left arrow, which is negative infinity because it's going down. This is positive and negative infinity because it's a right arrow and it's going down. So it says circle the end behavior, okay? As x approaches negative infinity, y approaches negative. That's one of them. As x approaches negative, y approaches positive. That's not right. Okay? As x approaches positive, y approaches negative. That's the other one, okay? All right, and x approaches negative, y. So all you got to do is label those errors. So we should be good at that by now. Okay, state the zeros and give their multiplicity. Very simple. X squared, that 0 is going to be x equals 2. multiplicity of 2. Okay, x plus 5, if you want to look at it this way, all right, that's just going to be x equals negative 5. All right, that's going to be no multiplicity. And then x minus 4 cubed, all right, that's really this, which is really going to be x equals 4. You're just changing the sign. That's a multiplicity, okay, of 3. All right, all the zeros of the polynomial. Write the equation of the polynomial in factored form. Okay, so multiplicity of 2, I'm going to put my f of x, means x minus 3 squared, because it would be 2. Okay, if that's going to be that, that's going to be x plus 1. So I'm changing the sign. Multiplicity of 2, just make that the exponent. Write out the equation of the polynomial in standard form. So what I'm going to do, all right, is I'm going to, squared means write that twice. So I'm going to use my boxes. That's x squared, negative 3x. Negative 3x and 9, okay? So I got x squared minus 6x plus 9, okay? Now, I'm going to multiply that by x plus 1, okay? So what I'm going to do is I'm going to do this. I'm going to write x squared minus 6x plus 9, x plus 1 going this way. That's x cubed, x squared, negative 6x squared, negative 6x, 9x, and 9. Once again, the diagonals is just like factoring stuff. The diagonals are the ones that are going to combine. So what I'm going to have for an answer out of this, I'll write it right here, is x cubed. All right, x and that would be negative 5x squared. Negative 6 and 9 would be 3. And then I got 9 here. Okay? So there's my answer there.